using cutting-edge approaches such as data analytics, machine learning, and artificial intelligence. So now our aim is to connect the mathematical problem with certain techniques like AI or any other machine learning technique. So nowadays many papers are coming from the different field solving the mathematical models or mathematical problems with the help of different type of machine learning techniques. So this is the scenario nowadays. These are the trends. Nowadays the trend of data science, or you can say that the optimization technique integrated with machine learning technique. There are many other things. So now, as a mathematics researcher, we also have to think how we connect all these recent trends with our problems.
Akshita, next slide.
Yeah, so intelligent computing, you know about intelligent computing. What is the meaning of intelligent computing? The intelligent computing means a design of computational intelligence based on soft computing environment is proposed for the researchers in the field of bioinformatics, represented with a higher nonlinear stiff and complex systems. So if we have complex problems, then how we will solve this type of complex nonlinear computing some techniques. So I think smart computing, or we can say that intelligent. Okay. So computation platforms are exploited to solve the nonlinear complex system associated with observability and precision, generally represented with ordinary and partial equations, or partial differential methods. There are different types of modeling where epidemic, pandemic, etc. So recently, we use different type of models like COVID, 19, HIV infection, cancer models, hantavirus models, and etc. So they are focusing here about the infectious disease model. Okay, how to solve the infectious disease model with the help of machine learning technique or computational intelligence technique. So those who are in the computer science background, they can catch these things very clearly. Those who are mathematics background, they can also understand how modeling is going to connect to this type of intelligent computing technique. Yeah, artificial intelligence or intelligent infrastructure means there are different type of deep learning technique. The artificial intelligence infrastructure is utilized for mathematical modeling of non-linear system, representing susceptible and protected, indicating super spreaders, infections, mosquitoes, fatality, and improving losses with supervised and supervised deep learning. So for deep learning, there are also different types of learning for supervised and unsupervised learning processes there. Those who are in computer science background, they can understand very easily. The effectiveness and performance of different optimization techniques in terms of constant and unconstrained problem are utilized for the solution recognized in the technique and dynamic models. So this type of techniques, this intelligent computing infrastructure is used to study different type of artificial, deep learning, including supervised and unsupervised learning. We understand when I will discuss with you more into the expressions that you can understand very easily. Yeah. So, there are, in my consideration, I divided this into three steps. Okay. The infrastructure consists in three parts, three steps. In first phase, new stochastic solvers model with Hermite, exponential, legendary, or basic. Any one of. Okay. There are different type of network system. Yeah. In the first phase, what we are doing, we are developing the new stochastic solvers to model with all these things. For any of these things, like there are different type of neural network. Okay. As well as warlike Mexican had made some modified neural Fibonacci or neural network. So in neural network also there are different type of neural network. Okay. So we can use any one and you can compare the result. Okay. So here you can see optimizing bio-inspired and naturally inspired artificial intelligence models for economies with a hybrid and a local search for computing deployment and procedure. So while using these type of technique, you will get more robust result as compared to the theoretical analysis or graphical analysis. So in the second phase, what we are doing, the existing as well as the newly structured meta-heuristic methods are investigated for the solution of complex nonlinear system to analyze and interpret the economics and pandemic pattern of a high-risk disease. Okay. So in the second phase, what we are doing, we are going to study about the high-risk category problems such as COVID-19 spread, HIV infection, and the virus model, HCV infection spread model, etc. Also, tumor growth model, that is, nowadays cancer cells studies with mathematics is very important. And in the third phase, we are using some technique like, for analysis, like finite analysis method or finite difference splitting method, based on the exponential Bessel, Hamilton, Rubin's, and Chebyshev's integrated with the global and local search schemes are designed for proving more reliable solution, predicting the epidemic pattern with variable strategies. So why we are using all these things? To predict the pattern, right? After considering all these things, we can predict the nature of the problem or nature of the system. Yeah, besides the implementation of artificial intelligence-based technique for the analysis of infectious disease model for both endemic and pandemic type, all the designed scheme are equally applicable to solve differential equation based on nonlinear system, such as similarity solution of bioinformatics models, nanotechnology, agriculture, aerospace, and financial mathematical problem. So this artificial neural network modeling or intelligent computational modeling have lot of application in different fields such as nanotechnology, agriculture, aerospace, and financial mathematical problems. So what are the features? The salient features of the proposed software computing algorithm are briefly given us. Okay, so these are some theory you have to understand. That means novel application of bio-inspired and nature-inspired computing algorithm to analyze the dynamics of governing complex nonlinear mathematical models for future prediction and control of epidemic diseases and feasible interpretation of the pandemic pattern of high-risk diseases. So this is the features, means we can predict, okay, and control, and we can suggest the control strategies. For example, high risk like COVID-19, I'm almost done. HIV infections, Handa virus, and tumor growth. All these are some diseases, which have much importance in the society. So, what is our purpose? Our purpose is to study and analyze, then give the prediction and control strategies. Next. Yeah. Now, second, the establishment of quality optimal solution in terms of accuracy, convergence, and stability by varying parameters of interest in the system. So, usually we are doing this, like convergence analysis, stability analysis. Those who are doing research in mathematical modeling, they can understand this. And finally, we will go for validation. Okay, validation of invariable correctness. So, for validation, we need the help of statisticians. Okay, we are finding the mean square, covariance, variance, and all these things. Okay, to check the performance. So, validation of invariable correctness is certified through experimentations and the statistical analysis in terms of indicators for the performance monitoring through statistical averages, variances, mean absolute deviations, mean absolute error, root mean square, and Nash Sutcliffe efficiency. Okay? So for statisticians, nowadays it is a collaborative thing now, because only mathematics people cannot complete everything. So there is a chance for collaboration with the data science people, computer science people, statistics people. So now the trend is moving towards this type of collaborative work. Next. So in order to have slight overview of proposed scheme, a design of neural network layer structure for the proposed epidemic biomathematical model is given in the following figures. So I would like to show how the model is constructed and what is the flow diagram, or we can say what is the schematic diagram of such model using the implementation of neural network. Accordingly, other neural network structure can be used to solve such type of or design such type of problem. So here I will show one example. After that, we can consider different type of problem to solve such type of examples. Now you can see this is the design of neural network structure for the problems. Okay. So what we are doing first we are designing a problem. Like you know that SIR or SIER, there are different type of mathematical model. So here I am using SITR models, right? Like mathematical modeling of epidemic disease spread system, design of SITR order based 4 classes. Okay, so SITR model suspected, susceptible, infected type model I am using here, and I consider an ODE system representation of epidemic model. So this design contains, you can see here, what is the meaning of S? S is a susceptible, and I is infectious, and T represented by under treatment, and R represented by recovery. So I have in front of me, I have this problem. Now I have to utilize this information to design further or to proceed with further step. Okay. Now in the next design, next. Okay. Here you can see reference data set. So here state of the art numerical method for generation of data set. Now next step what we are doing, we have to generate the data set. Okay. Firstly you have the model. From that model we have to generate the data set. Now there are different type of opportunities. Either you collect the data from the hospital or medical practitioner or somewhere else. For example, if you are working in a big university, then there will be a medical college or there are some hospital and they have data and internally you have the permission to use the data, or you can collect the data from after taking permission you can collect the data from the hospital and use it. Otherwise what we are doing, we are as a mathematician, we are modeling the problem and after that we are generating the data. Then after that, intelligent computing infrastructure to solve the strict biomathematical real system developed for epidemics and diseases. Now you can see this is my mathematical modeling. This is little complicated, but those who are in mathematics field, they can very easily understand how to model the system. The changes susceptible, infected, under treatment. Okay, all these things are considered. So simply I just show that this is the reference data set and this is the mathematical models. Now after that what we are doing, this is the next step, that means we are applying the neural network concept. Okay, so neural network model, design neural network layout structure for the proposed epidemic biomathematical models. Okay, so next time what we are doing, we are considering some data for testing, training and validation. Okay. So if you are using the new computer science and I did my PhD from engineering faculty, so I have knowledge in such a type of concept. And after that you can see application of nature inspired computing algorithm to analyze the dynamics of governing complex nonlinear mathematical models. So finally we have to analyze the result, that is using statistical technique like accuracy, convergence and stability by varying parameters, and compare the mean square error, fitness, regression error, statistical measure for all the variables. So now our paper is done. So you can see stepwise. First we are starting with some model and generating the data. Then we are using some machine learning technique. Here I am using neural network. Even in neural network there are different type of neural network. Legendary neural network, Mayer neural network. And there are different methods like the Lobotom method, Bayesian algorithm method, there are many things. So from one concept, you can find different flavors of paper with different results. Okay. And to make the attraction of the paper, we have to do the visualization. For that, we will do this result analysis and by considering different type of statistical measures. Now here you can see it's look like very simple, but it's not much simple. You can see here the schematic diagram of that model. So here what we have, you can see here I defined all the parameters. Okay, and you can see these structures here I have input data. Then there is some hidden layers of network. After that output data. So it is something like a system identification. Something is giving here in the input, and we are getting the output, and there are some process inside the box, hidden box, or we can say hidden layer. For that, we have to consider different type of neurons and operations. Okay, so this is quite interesting. If you can, study more about this type of thing, you can see mathematics is not like only theoretical way of study. It has many practical application and it has a potential application in various fields. Okay. Now, while modifying these ways, you will get a different type of results. So that is the beauty of using such a type of techniques. Next. Now, mathematical modeling, you know that everything can be considered as a mathematical model. Even a simple equation, simple expressions. Yeah, we can connect everything with mathematical modeling. So I'm not talking much about mathematical modeling. Next. So there are different type of mathematical modeling are available. So here our interest is about the intelligent computing and mathematical modeling. So here data-driven modeling and machine learning. So what are the models? Models here, first we have hybrid models, means combining traditional mathematical model with machine learning techniques to improve accuracy and predictive power. For example, integrating differential equation with neural network. I already explained that one. How to integrate that differential equation with the neural network. That is called hybrid models. Second one, surrogate models, means using machine learning to create simplified computationally efficient model of complex system. Okay. So machine learning technique, there are different type of machine learning technique, optimization techniques are there. And the third one, explainable AI, that means developing mathematical framework to decode and explain machine learning model, ensuring transparency and trustworthiness. So my interest is in the first one, that is hybrid model. So here you can see the example. Yeah, here you can see integrated intelligent neuroevolutionary computing approach to study the STIMC model representing combinobacteriosis transmission dynamics. So here you can see this paper published recently, and here we used neural network concept. Okay, and this is about the combinobacteriosis. Okay, next. Combinobacteriosis that can be make people ill with diarrhea. The illness is called combinobacteriosis. Combinobacter was the most bacterial diarrhea illness in the United States. CDC estimates 1.5 million people in the USA get ill from Campylobacter every year. So, this study is very important because every year only in US 1.5 million people affected with this bacteria. So this type of study will give you the value because it's even we are not bothered about this type of bacteria. So if we are considering the Indian population, maybe the number is more. So there is a chance use such type of data to study. Means once you can collect the data, you can do hundreds of papers. That is the beauty of using intelligent computing technique. Yeah, go ahead. Yeah, this is a model here. You can see model for nonlinear combinobacteriosis transmission. So here you can see I used some classes. That is 5 classes: susceptible, exposed, infected, recovered, and bacterial population are used in this model. And then next. So these are the CBCT model. I mean CBT model. That means there are 5 classes. Next. Yeah, there are some parameters, for mathematical modeling, you have to define the values and you have to give the parameter values and all. So, so here what is the things used? The ANN LSGS2. This GS is the genetic, escaping sequential quadratic programming system is set up to function in two phases. That is an ANN-based CBT model and a fitness-based log sigmoid function described. So the necessary information given in the automatic GA, that means the genetic algorithm, and escaping sequential quadratic programming to enhance the function based on the fitness of the CBT model. So you can see this paper is not a simple paper. Here many techniques are used. We used artificial neural network. Then after that we used a genetic algorithm. Then sequential quadratic programming, and we use the combined form of this. But if you use only genetic algorithm also, you will get a good result because GI is one of the famous algorithm for such type of problems. Next. So here you can see these are the problem formulation. All the things before I explained, technique used, mathematical model of CBT, the technique used, then exact approximation of the solution. So these are the system. The design I already showed you before. So here you can see that design I used in this paper. Next. So here the result, this ANN-LS is optimized by repeating the paradigm 100 times to get larger data set, keep a record of weight, fitness, age, generation, and function count. Additionally, MAD, RMSC, and TAC are used to validate the authentication. These are some statistical data, root mean square error and all. Next. So conclusion, I told you that we are using this. We can conclude that high effectiveness of suggested intelligent solver with AE's line ranges from this to this. The performance convergence criteria which are calculated for 100 years demonstrate how well this suggested solution meets the stringent criteria. Additionally, statistical explanation of 100 different sets using all these parameters or all these variables are used to study the applicability of the result. So, like that, using this study, easily you can predict some positiveness to the this type of problems. So there are different type of model. Instead of going to only single model, you can consider different type of model like epidemiological model, personalized medicine model, system biology models, etc. Next. Okay, like here you can see, here we used new insight into disease dynamics and treatment with PID control based therapeutic strategy in pancreatic cancer. So in mathematics, we are considering more important things like tumor studies, something like different type of endemic and pandemic. So this is the beauty of mathematics. You can consider different type of data, and this journal is very important, very good journal, computers and mathematics with application, and in this one published very recently. Next. And findings here we developed mathematical model for pancreatic cancer progression using a system of nonlinear partial differential equations with the time t, capturing disease dynamics in the human body. The model represents 6 key cells population involved in pancreatic cancer. C is cancer cell, pancreatic stellate cells and storm cells, extracellular matrix preamble enzymes, tumor-associated macrophages, and immunosuppressive cells, etc. So, these are some parameters we have to consider while modeling the problem. Next. See, you can see it's not easy to model the problem. There are many things you have to consider. So this is, you can say the schematic diagram of PD model with the diffusion coefficient. So here we consider many parameters. That is why it's look like little complicated. But the results are very excellent. So, next. Here, see, these are the parameters we used. Okay. Here, the variables and the descriptions are given. Next. And this is also more parameters are mentioned here. Next. Yeah. So this is the model. Okay. This is the mathematical model, and you can see this is the partial differential equation. So I don't want to explain these things here. Next. And in the conclusion, the study represents detailed exploration of treatment dynamics in pancreatic cancer, utilizing an advanced mathematical model based on partial differential equation with the delay. That is very important. Here we are not only considering the partial differential equation, but partial differential equation with the delay. Okay. Through the integration of optimization techniques and periodic feedback control, we have designed a critical insight into how dynamic population treatment intervention can be influenced disease progression and immuno for cancer. Okay. So growth of cancer cell is very dangerous. So based on that, here we have some control strategies. Our research emphasizes the importance of treatment timing, particularly with regard to surgical resection, and suggests that early surgical intervention is crucial for maximizing efficacy by targeting primary tumor masses and reducing overall tumor burden. So, without a medical support, without any medical support, we can predict or we can suggest some control strategies. Okay? I think the time is now over. I will just show you some slides just to motivate you, but I will speak quickly. Okay? Because I just want to show that in mathematics everything is possible. We can do different type of papers. We can connect our technique with the different areas better. So just I want to show. Okay, next. So here you can see mathematical analysis and chaotic behavior of cancer treatment with virotherapy by using fractional integral sustainable approach. So this is also about the cancer related studies. Next. Similarly, we can model climate and environment. Okay, we can consider different type of data for climate change prediction, sustainability models, ecosystem dynamics. Next. So here you can see the paper. It's also in one of the top journal. That means stability and chemical modeling of quantifying disparities in atmospheric analysis with the sustainable fractal fraction approach. So here we use the concept of fractal fraction approach to model the chemical modeling of the quantifying disparities in atmospheric analysis. So similarly, there are different type of field like optimization and controlling engineering, smart manufacturing, autonomous system, and energy system. Next. So here you can see this paper is about fraction order forestry resources, conservation model for featuring cows control, and simulation for toxin activity and human host fire through modified operator. ABC operator is Atangana Valana Capital. This is a fractional operator. So we use that operator to model such type of problems. Next. So here, if you are interested, there is a survey paper, that is survey of energy efficient home computing techniques and recent advances. These are papers published recently in book journals. Next. So another one is network science and complex system. Okay, if you are interested to integrate the intelligent computing with mathematics, we can go with these things like social science, social network, infrastructure network, biological network. Those who are in graph theory, they can also do something in this direction. Okay, because there is a network connection with the graph. Now here you can see this is okay. Next, this is yeah. This one is in IEEE journal, and this is related to unmanned aerial vehicle with communication system. Next. So in the disciplinary application, economics and finance, social sciences, sports analytics. Next. So here you can see this paper is about cows and forecasting financial risk dynamics with the different stochastic economic factors by using fractional operators. So my work is focused on fractional operators. and I just try to connect the different type of technique with interdisciplinary application, like it is in the financial risk dynamics. Okay, next. So those who are interested, they can use this open source software, increasing use of tools like Python, R and Julia for mathematical modeling, and collaborative platform for code and on GitHub, GitLab for sharing code, mathematical code and models for forecasting collaboration across the discipline. So these are the openly available platforms. Now see, this is in conclusion. This table is important, like mathematical modeling. What happened? There is data-driven machine learning integration and explainable AI. Okay. Multi-scale means multi-physics coupled system, healthcare, epidemiology, personalized medicine, climate, sustainability ecosystem, optimization, autonomous system, energy system, network science, social network, and biological network. So there are many areas. Okay, we can implement such type of concept. Here you can see everything is in order. Data-driven means machine learning integration of explainable AI, and multi-scale means multi-scale means multi-physics or computer system, etc. Next. So here you can see one paper. This is in neural computing and application in this channel, and this is about the design of an evolutionary optimization network for transmission dynamics and control of volume glucose in cattle. Okay, so this paper also about mathematical modeling with the help of neural network. Next. Okay, there are many papers. I don't want to explain everything. This is also, I just want to show that applying intelligent computing technique will widely accepted the community and you will get a quick response. So on this recent paper, this is about again intelligent computing application in rumor spread model. Okay, rumor spread modeling. So next, there are many papers. This is about a nanopod model. Next, this is about Ebola virus disease. Next. This is about fine white disease for with the sequential quadratic programming. We use neural network here. Next, here we use another soft computing technique for MHD problems, that means fluid dynamics. Next, and here intelligent computing technique for hybrid nanofluid. Next. Here, Mayer wavelength neural network is used to study the epidemiological smoking model. Okay, epidemiological smoking model. Next. So you can see these are the some of my work related to intelligent computing. There are hundreds of work, but I just want to, if I am going to explain everything, because I use different technique, like some Mayer wavelength, some places legendary neural network, some places genetic algorithm, some places SQRP, so like that. So I just want to show that it's easy if you are trying to collaborate with some computer science people, because they can understand the practical things. We are good in theoretical work, and they will help you to understand the practical things, like how to apply the genetic algorithm. They are waiting for the idea. Okay, so mathematician can provide different ideas because we have different methodologies. Okay, so I think you understand little, or maybe you can do something in this direction. Thank you so much for listening.
Thank you, sir. Every great conference begins with a spark of inspiration, and we are honored to receive that today from our keynote speaker. Please put your hands together for Professor K. Suthu. Thank you very much, sir. To illuminate this gathering with visionary thoughts and expert insight, and pleased to call upon Bharadwaj from LFDC Farewel to introduce our distinguished speaker, Professor Shankar Rao.
Good afternoon, everyone. It is my distinct honor to introduce our next distinguished speaker, Dr. Shankar Rao Manjan. Hails from Telangana, India. He currently serves as an instructor of mathematics at the University of the People, USA, and as director and scientist at Patent IPR Innovative Solutions in Hyderabad. His academic journey includes an MSc from KU, both his MPhil and PhD from Pondicherry University, where his 2016 thesis focused on nonlinear differential equations in fluid dynamics and their solutions by homotopy analysis. He further honed his expertise as a postdoctoral fellow in applied mathematics at Shanghai Jiaotong University, China. Here, he collaborated with the distinguished professor Shijin Liao, a highly cited researcher and founder of the HAM method, leading Dr. Munjam to propose new analytical techniques like fractional homotopy analysis method. Notably, he recently received a 10-year high-level foreign talents visa from China to continue his postdoctoral work at Shandong University. Dr. Munjam's extensive career also includes roles as lecturer and an adjunct assistant professor at LIT Nagpur. He boasts an impressive 58 publications, including 14 in SCI journals and 18 in SCOPUs and 10 granted patents. He is an active member of professional bodies and executive council member of APTSMS and a reviewer for 87 international journals. His numerous accolades include international postdoctoral fellowships from Shandong University and Shanghai Jiaotong University, and the Professor Meenakshi Sundaram Memorial Best Paper Award, Outstanding Contribution in Reviewer Awards from Ames Engineering Journal 2017 and 18, and the Best Researcher Award for academic year 23 to 24 from Oxford University. Dr. Munjam has also been a key organizer for major international events, including the DST SCRB sponsored International Conference on Mathematical Modeling and Emerging Trends in Computing 2023, and international FDPs and workshops at Oxford University. Ladies and gentlemen, Dr. Shankar Munjam is a leading figure in applied mathematics with significant contributions to research, education, and innovation. We are truly honored to have him with us. Please give a warm round of applause for Dr. Shankar Munjam.
Good afternoon, Manadal. Yeah, how are you all? How? No, this is simply I am asking that how you are fine. Yeah, you had a good food and easiest food. Yes. Yes. Very good. So, yeah, I would like to thank the organizing entire team and student fraternity of this institute. And also, I would like to thank myself. I'm having the one startup organization, IPR, Patent Rights Innovative Solutions in Karnataka, Hyderabad. So, presently, the trend of mathematics, how it is increasing the capability of science and technology. Today. Yeah. You know that how the importance of mathematics nowadays. It is very simple that A plus B whole square mean everyone know how to define. But what is A, what is a B mean? That is a complicated solution. And you know very simple x plus y equal to 0 mean you will get solution. Very simple. And you know that very simply x square plus y square equal to 0. You know? Yes? How to find a solution? And square root of x square plus square root of x cube equal to something 0, then you will get some solution. Yes? So, see, we have to start a fundamentally, basically, then how do we can start a system of linear equations, and how do we can find a solution of system of non-linear equations. That is a very important of these days. So my intent is to give brief on how to find a solution of non-linear fractional order differential equations. That is a system of non-linear highly equations. The name is that Wonderful. He defined that one system of equation in 1970 in April 20. Then he written the concept of what type of significance by using the solution will occur either any numerical method or analytical method, and how we can find. Then he defined for system of equations in 1970. Fundamentally he defined only for he solved one equation, single equation with a simple conditions. The simple condition means in initial conditions. The boundary condition means it is very tough to find the solutions. Yes. So here I have considered for analytical solution for system of nonlinear fractional differential equation by using newly we and my guide Professor C. Jun Liao from Shanghai Jiao University, Shanghai. We propose a new technique that is a YAM. The I is very small. Please you can check why. Please observe it. Capital M, capital D, then small I and capital M. Can you write like that? No. Yeah, but we have proposed that one method of directly defined inverse mapping. Yes, what is that? It is a newly proposed from the we have used some basic concept from the homotopy analysis method and some homotopy perturbation method and homotopy transpose methods and homotopy inverse method. From that fundamentals we have considered and we have proposed a new method that is the MDDI. In 2016, when I was joined as a postdoc fellow under the guide of my supervisor, we found the new technique as well as a new solution to find a system of fractional order equations. That is our motto, and we did, and we also solved many problems on similar type of in engineering and sciences. So, next slide. Next. See, in my talk, I have considered that here the difference between the in phase and out of the phase of the theoretical solution, how it is a system is improving the how do we can solve the fractional order differential equation of wonderful wonderful equations by using the we have taken the different initial profile. That is the initial profiles we have initial. That is the we only consider in the first paper of this independent initial profile we have considered. I have taken that amplitude and different frequency we found in different phenomena in phase and out of phase. That is a new era of the work. Next. Also, I have discussed on autonomous and non-autonomous mean behind some different physical parameters having the different values. So that is a based on that values we have considered and we have found the double well, force weight rate as well as the time we can call it time trajectories of a, we can simply we can call it graphs. Time trajectories or time history curves. What is that? Time history curves. Then also effect of various parameters we found, and we can discuss in this next slide. This slide. The next. And where it is a useful mean, not only one mathematical subject we can find, so it is found in many areas, applied mathematics, physics, biology, and finance, and many other, what is that, sectors. We can use the fractional derivatives and we can find the solution in various directions, and the finding the solution of this type of, what is that, non-linear phenomena, it is a very tough task, you know already. So, but finding a solution directly, it is very tough, and we get, what is that? We have to spend more time to find a general solution. So for that one, I took one problem, 2 years to solve this problem. I took only, what is that? One problem to solve, I have taken 2 years. So then only we got a new solution. Next. See, focus of the project study is that the approximate analytical solution. While we can find a general solution, behind the many type of solution. Numerical solution, exact solution, approximate analytical solution. So while approximate means nearby value of that solution. So an approximate analytical method, the MDDI method is nothing but this is a method of directly defined inverse is nothing but an approximate analytical tool or method to find a general solution of van der Waals equations, and it is not available in the literature. So we have considered all the parameters at a time, and we have found the approximate solution, and also we have analyzed that how the periodic solution by using the scientific profile in sine graph and cos graph, how we can utilize here, and we have found the solution of these wonderful equations. Next one. And especially for this study is that already we have discussed with the different parameters. Yes, next. See, these are the governing equations. Governing equation means, you know, the standard equation we have it with the, see, we have the operator d power of 2 alpha. Alpha is the order of fractions. D is a, what is that? Derivative. It is a fractional derivatives. So you can take alpha equal to 1 means second derivative. You can take alpha equal to 3 means, yeah, please you can observe. Alpha equal to 3, we can assume. What you will get? Alpha equal to 1 means, first you can check equation number 1. dt means t correspond time d to alpha. Alpha equal to 1 means that is a second order derivative. Nothing is there. About alpha equal to 1 by 2, what you will get? 1. Nothing is there. We can solve. Anyone will solve. Alpha equal to 1 by 3, what you will get? Alpha equal to 1 by 7, what you will get? So we have to think the fractions where it is occurring, then what is useful, and how to we can find the general solution of this type of problem. It is a very tough task. Even though by using the, what is that, some approximate analytical tools, we can find this type of homogeneous equations by using MDDI method. Find the initial profiles, means initial conditions we have it. See, it is a very simple that we assume first A, B. A is a one parameter and B also another parameter, and omega. We have considered in omega means that is a, what is that, amplitude. How to we can exchange the values, then or we can how to we can increase the fractional values, and how it is predicting the solution. So that purpose only we have assumed in first time. Next one. And we had first time attempt of these equations to solve the by using the MDDI method. Next. By using the MDDI method, we have to assume, mean we have to take some base functions. It is a very simple that. Okay, generally we have to assume first, what is that? I have taken the class and scientific functions with the corresponding solution. In solution expression, we are expecting that maybe our solution is based on this. So it is expected only means we have to assume, we have to choose only, or we have to select only. Then we have selected these uj and vj to general solution expression. From that expression, we are expecting that suppose u1. Before that, we have to find u0. U0 is nothing but initial profile. Means it should be satisfy the given initial conditions. So we have to find from this solution expression u1 means first approximation solution, u2 second approximation solution, u3 third approximation solution, so on up to 15 order approximation solutions we get, and also more than 50 also we get by the using the what is that we have to use which type of softwares, any Maple or Mathematica. So you will get the 100 or thousands time of the approximation solutions we use. Correct? So before that, we have to take the some initial profiles. That is a very important that initial profile means U naught means that is a we are considering. So it is a satisfying only unique solution. So in any interviews, they will ask you suppose why you are taking the initial profile. So it should be consistent and we can get the basic initial profile and it should be satisfy the given initial condition. From that type only, we have assumed that U naught and V naught, where we have taken the two, what is that, some approximations of, what is that, arbitrary values in A, B, or B and C, so on. Correct? And the inverse operators, we have defined in first way, I mean, we have the two equations, U and V, so corresponding the L operators. L operators mean inverse operator we have defined in L inverse and V inverse. Sorry, L inverse at U and L inverse of V. Mean we having the two different inverse operators. Mean that's why we can call this method is method of directly defined inverse mapping. Then where we are using the mapping and here functions are occurring. How do you can find the what is that? Mapping. Mean from here we have to write a algorithm. We have to write a algorithm. We have to transform. Mean we have to take the zeroth order deformation equation. We have to take the higher order deformation equation. Then we have to find the solution. For that purpose only, okay, we have to develop a first type of some algorithm. Then only you will get a proper solution. So how we will get the solution? Mean next. Mean we found in phase periodic solution having the what is that omega and a. These are the we have taken amplitude and frequencies. Having the in phase mean we got a value of m. In out of phase mean we got square root of 1 minus 2m. So that is the difference between in phase and out of phase. So for that purpose only we got a different time zone. I mean time frictions, and we got what is that we can call it double well and single well graphs. Double well and single well. So next one. And result analysis. See, actually any equation having some error analysis. So how do we can find it? Error means so it is a typically we will get the that values. See here we utilize the scalar residual error analysis equations. From that we got some different approximation. M equal to 1 to we found that up to 15th order approximation. See why we found up to 30th approximation order. See the values are having some having some fraction of changes. After this, what is that 40 approximations, we got consistency of the result. We got the consistency of the result. So that's why we have to find how we can find it by solving the equations, and we have to use the Taylor series. If our problem is initial value problem, mean we have considered at zero, mean we have taken the Taylor series, we found the error analysis. Okay, next. And also we found the autonomous and non-autonomous. Mean here how the frequencies are increasing when in phase and out of phase. Always in here also in autonomous and non-autonomous cases also it is slightly decreasing. Next, with various different values, and also the time history curves it is occurring in different ways. You know that in sine function it will start from the zero and so on, so it is a declimating. And also in cos function is already it will start from the -1 to +1. But we have assumed in this problem is that -2 to +2 because of we got a different amplitude values and we got different different frequency values. So we have considered here different f mean f is f and g both values are the arbitrary values we have considered. We have taken some different parametric values and we found that these are the geometrical mean sketch of the figure 1 and 2. Mean these figures comes from the our initial profile only. Initial case what we have assumed that we have assumed that a initial profile u naught is nothing but we have taken the one function and v naught we have taken the two functions. So from that solution only we got the time history curves. Next, and here very important that we found what is that how we can check the behavior of the solution. That is a very important. See here it is nothing but see here there is x0 u dash xi versus u. We found that there is some time diffraction is there with different fraction values we are increasing the fourth bracket of the curves under u is how it is increasing. And please you can check another v dash to v down. So it is also there is no diplomatic increasing. What is that? It is like that simply a monotonical increase. Curves is that. But in first phase, first u dash to u curve, please you can check how it is the effective of epsilon values and the what is that? You know that there is some increasing, suddenly increasing and suddenly decreasing which here occurring. So that is the novelty of this problem. Okay, novelty of this problem to solve by using the NVIDIA method. Next, so the beauty of wonderful fractional equation is that we found in different phase plane of the Vijay. So here say you can observe that we have considered the up to 15 fractional approximations, the how the behavior is occurring. So there up to 35 approximation we are getting see some white bubbles are there in up to 35 approximation. After 35 approximation, our solution error analysis we are getting equal. Mean all the values are getting equal. That is the beauty of this problem. Yes, next one. And here also same. Next, the conclusion is that the amplitude is increases. The important is that for who are studying in physics, maths, or chemistry, and they have to observe. Even though I am teaching in MBBS students, they are studying in algebraic mathematics in USA. So how the amplitude is increases and frequencies decreases, then we can observe not only in mathematical faculty. So anyone they will observe these frequencies. See the amplitude increases and the frequency of in-phase periodic solution decreases rapidly, suddenly. Due to the we have to increase the what is that fraction of orders in alpha values we have to increase. And another important thing is that frequency of out of phase solution. What is that? It is a decreasing monotony. We have observed in we have seen in V graph. in WL of the V graph, then amplitude is increasing slightly. Okay. So that is our observations, and it is a very very important and not only this importance of these studies, and you can try to only single equation to solve any standard approximate analytical methods. Okay, then you can check the behavior of the solution, then you will get what is that? Approximate analytical solutions. Next, if you have any doubts, please any doubt? Yes. Next, thank you. Thank you very much for giving this opportunity. So thank you.
Thank you, sir. I now invite Asher Frank from LPCA second year to introduce our valued keynote speaker, Dr. Ajmira Chandula.
Dr. Ajmira Chandalal has obtained MScs, ML, and PhD in mathematics from Kakatiya University, Warangal, Telangana, India. His working career started as a school assistant in mathematics in Khammam, Telangana. Then he joined as an assistant professor in Department of Mathematics in Rashtriya Sanskrit Vidyapita, now referred as National Sanskrit University, Tirupati, Andhra Pradesh. He has also visited Australia, Thailand, and Oman to present his papers and as a session chair. He has published 27 papers in national and international journals. He has also held several academic positions as a member of BOS and HOD in mathematics, and also as an NSS coordinator. He has also been appointed as liaison officer of university. He has also organized a national and international conference with Association of APTSMS. He is also a life member in professional bodies like Indian Mathematical Sciences, APTSMS, and Indian Science Congress. He has also delivered 4 of the invited talks at different conferences. His research area is in solid mechanics. To illuminate this gathering with visionary thoughts and expert insight, I am pleased to call upon our keynote speaker, Dr. Ajmira Chandulal. Please join me in extending a warm welcome.
Good evening, everyone.
Very good afternoon to all the participants. Till now, the sessions have come up. Today, the participants are going to present their presentations. So, I would like to call Ms. Rekha Sinha Madam to please present the paper. Now I request our principal, Ms. Jayanti Reddy ma'am, to please felicitate our resource person, Professor Nisa. Sir, please. Thank you very much, ma'am. Now I request Rekha Sinha to please present the paper in the Senate.
Thank you, sir. Thank you, Little Power School, for giving me this opportunity. So, myself, Rekha Sinha, and I am a PhD scholar from Beacon University in my third year and working as Vice Principal from Omega Degree College. So, this is my second paper presentation. My guide is Dr. Jadav Ganesh sir from Geetam University. So I'm working on this paper name called on minimum attaining operator. So operator is just like function only, but in function we have limited number of dimensions we can say, but operator theory is dealing with infinite dimensional. So yeah, please. Yeah. So this is the first slide. Yeah, go to next, please. So this is my plan of talk. Some basic notations, some preliminaries, norm attaining operator, minimum attaining operator, existing research work, literature survey that I have done, research work done, future plan publications, conferences and workshop, and some references. Next. So here are some notation that I am going to use throughout my paper. H, that is, stands for separable Hilbert space over complex field. Everybody knows what is complex number, real numbers, those who are dealing with mathematics. So here I am talking about Hilbert space. Hilbert space generally dealing with infinite dimensional space, and H is unit sphere of H, Hilbert space, and BH is open unit ball of H. I is the identity operator, R plus is the set of all positive real numbers. So first I'll start with the definition of bounded operator. An operator which is T from H to H is said to be bounded if there exists alpha, which is a real number, positive real number, such that norm of Tx is less than equal to alpha times norm of x for all x belongs to Hilbert space H. So what is norm first of all? Norm is nothing but, it's just like a function, but as I told you, we are like in operator theory, Hilbert space is dealing with infinite dimensions. So here, a norm of T is nothing but supremum of all Tx for all x belongs to Sh. This is only the norm definition. And the next notation is BH, the set of all bounded operator on H. Here are some example of operators that I am writing here, which is bounded. First is identity operator, and norm of I is 1. Next we have the operator T, which is from R square to R square, defined as T of x comma y is x comma 0, the ordered pairs. For all x y belongs to R square. Here also the norm of T is 1. Then we have this right shift operator on L square. This is R denotes right shift operator. So here if I am taking one sequence x1, x2, x3 dot dot and so on, and applying R right shift operator, it is shifting one place the element and giving as the answer 0, x1, x2, x3 and so on. So here also when we calculate the norm for right shift operator, it is 1. So these are some examples for bounded operators. Next we have adjoint. So all these are the basic things that I am just explaining before telling what is the theorem or the lemmas that I have I'm working on it, and I got the proofs also. Basically my paper is a pure mathematics paper, and here only new theorem, new operators I am going to explain. So it's not applied math, it's pure math. So I hope people will not find it boring. It's boring little, but please bear with me. And adjoint of operator is nothing but if you take inner product space of Tx comma y, then it will give you x comma sy. So here the adjoint of the operator T is T star, which is nothing but S. So this is about the adjoint of the operator T. Here I have the example of adjoint for right shift operator. The left shift operator is the adjoint. So R star is nothing but L. Then some definitions, some different type of operators that I'm going to use in my proof, that is isometry operator. For that, the norm of Px is always norm x for all x belongs to H. Compact operator, filtering closure of all T of BH, it is compact in H. Problem? Okay. So these are just the basic here. Few remarks, just as read, sir. That normal operator quasi is a subset of quasi-normal operator. It is subset of hypernormal, and it is subset of paranormal operator. Next, please. So here again some example of that thing only, that if R is quasi-normal but not normal, some examples I have put here. And then definition of norm operator. When we call operator is norm operator, if norm of T is equal to norm of T x naught. If I got a x naught in the Hilbert space SH, like open ball, or open sphere SH, we are taking one element. So if I am getting a element whose norm is equal to norm of the operator, then the operator is called norm attaining operator. So NH is the notation for norm attaining operator. Next. So this is some literature survey I have done for the norm attaining operator. I have read all these papers for working on minimum attaining operator. Next. So here comes the minimum attaining operator definition first. So here minimum attaining operator is nothing but it is infimum of all norm Tx such that x belongs to open sphere. SH is called minimum attaining operator, and T is said to be minimum attaining if there exists an element x naught in SH such that MT is equal to norm of Tx naught. And MH is the notation I am using for minimum attaining operator. And few examples of minimum attaining operator are non-injective operator, and every isometry operator are minimum attaining operator. Next. So this is the literature survey, and these are the existing result propositions for minimum attaining operator, that if T is a bounded operator, be a positive operator, then T belongs to minimum attaining operator if and only if MT is an eigenvalue of T. And the second proposition, which is existing result only, that T belongs to BH, be a compact operator with dimension H infinite, then T belongs to MH if and only if T is non-injective. Next. So this is the existing, one more definition, that is invariant subspace. Because I am combining a minimum attaining operator, invariant subspace, everything in my results, sir. So that's why this definition I am giving for invariant subspace. So a subspace is called invariant if P of that subspace is subset of W. So here are some example of invariant subspace, that is identity operator, and this one result from R square to R square, which is again invariant subspace. And this is the existing result. Here T is a norm attaining operator, is a paranormal operator, then T has a non-trivial invariant subspace, and hence norm attaining hypernormal operator have a non-trivial invariant subspace. So this is the existing result that I am using in my proof. Next. This is the research work I have done, the lemma, first lemma, which says that T belongs to bounded operator set, then the set M, which is x belongs to H such that norm of Px is MT into norm x is a closed subspace of H. This result, the proof I have submitted in one of the publication. And the second result also is T belongs to minimum attaining operator is a quasi-normal operator, then T has a non-trivial invariant subspace. And here is the example of weighted shift operator. So weighted shift operator for a bounded sequence of positive real number. If we have the weighted shift operator, W alpha on L square is defined as W alpha into En is alpha n En plus 1, where En are all the standard orthonormal basis of for L square. This result, also one more result based on weighted shift operator I got, that is W alpha is minimum attaining if and only if M of W alpha is alpha I for some I. So these are the some result. Next. And these are the two questions that I'm working on it, but still not get the proper proof. So I'm working on these two problems. That first is if P is minimum attaining operator, be a hypernormal operator, does P have a non-trivial invariance of space? And the second is again if it is minimum attaining and a paranormal operator, does P have a non-trivial invariance of space? Next. And this is my Ganesh reference of paper is there that I'm referring. And one paper we have communicated, the last one, Rekha Sinha and J. Ganesh, a note on minimum attaining operator. Next. Thank you.
What is your conclusion about that?
So conclusion is like, see, we are like as I told you, it's a pure math paper. So here it's not applied like to real life situation, but we are just getting the new theorems or new operator. Definitely these operators will be applied in the real world situation also, in applied mathematics also. But I'm working on pure math part.
Any more questions from
Any
audience?
question, yeah, please.
From audience? Okay. Thank you, Rekha.
Thank you, sir. Thank you so much. Thank you.
Thank you very much, ma'am, for giving a presentation on the theoretical part of mathematics. Now I request our next participant is Bhavana madam. So I request her to please present the paper.
My name is Bhavana. I'm research scholar under the guidance of my research topic is cryptography. Now I'm presenting paper on the role of n-based number system using cryptography applications. These are contents in my topic. In today's digital era, security information is essential from online banking to military communication. So cryptography plays a central role in data from unauthorized access. At the heart of many cryptographic methods lies powerful mathematical tool in using number system like binary, decimal, hexadecimal systems are well known. In this paper, I would like to use n-based number system. So the base, the base is the simplest case of numbers, unique digits, including zero, that the positional numerical systems use represent numbers. Here, the fundamental theorem of arithmetic established the important prime numbers, that prime numbers are basic building blocks of positive integers. In new number system like n-based number system is allowing zeros and ones digit using n primes, the powers of primes respectively. For example, 31 can be represented as 2 to the power of 1, 3 to the power of 1, 5 to the power of 0, plus 2 to the power of 0, 3 to the power of 1, and 5 to the power of 1, plus 2 to the power of 1, 3 to the power of 0, and 5 to the power of 1. So these are my literature reviews, and this is my proposed algorithm, and this is application for that proposed algorithm. First, we convert one message happy into prime based numerical strings. That here we are taking the primes 2, 3, 7. Here fixed block size is 9 digits. So convert happy into ASCII code. So the base is repeated as cycles, that is 1 to 9, and base is used 237, 237, 237. Suppose here 104 by 2, that I will take remainder 0, and the quotient is 52. And next prime number, that is 3, 52 by 3, the remainder is 1, and quotient is 17, like this. Here given the plain text h is equal to some 0130 100 so on. So doing like this, doing like the alphabets, we get 45 digits number, that is encrypted string. So this is conclusion. The proposed encryption schemes leverages the flexibility and mathematical richness of the n-based number system and transformative power. And the hybrid approach introduced a new dimension of security encoding potentiality, enhancing cryptographic robustness, inspiring the further research mathematical cryptography. These are the references for my topic. Thank you.
Bhavana,
Sir,
what is your main theme of your paper?
using n-based number system,
Number system.
n-based number system,
N-based.
n-based.
What do you mean by N?
Base number system base n. Binary base is 2, hexadecimal base is 8. Like that, I am using base is 8, base is n.
Good. Audience, please, any questions? No more questions? Thank you, Bhavana. Thank you.
Thank you.
Any more paper projectors?
So from
No?
all, so
Are you good?
from online, Harita, someone is ready to present the paper.
No, sir. Dr. Balayogi is ready, ma'am. Dr. Balayogi online presentation ready.
Yes, sir. Good afternoon, sir. This is Harita. Connect now. Give mic. Sir, good afternoon, sir. This is Harita. You are giving a chance to me. Shall I present my paper, sir? Harita.
Okay, huh? Thank you, sir. Yes, question, Harita garu.
Yes, thank you, sir. Sir, is my screen is visible, sir?
No.
Yes, sir.
No.
Okay, thank you, sir. Good afternoon, one and all. This is Harita. I'm the scholar.
Screen is not visible.
Screen not visible.
Say it again.
Screen is okay, but content is not available. Please stop the screen share, again share. Share again, don't click. Tension or don't tension. Good. Arrow mark is there. Just click on arrow mark. Upward arrow mark.
Sir, some screen not sharing, sir. Please.
They can send it to the mail ID.
I'm logging with the online laptop, sir.
Okay, no problem. Just
Here screenshot option is there, but
your
not sharing my
PPT,
screen.
so open your PPT, then go for screen share option.
Yes, sir.
Now try again, screen share.
Yeah, the screen will be display here. Chrome tab window entire screen.
Entire screen, okay.
But here entire screen, I clicked it.
The Windows, sir.
Windows. Stop your screen.
Hello.
Sir,
We do one thing, we just share your PPT to international conference at LFDC.edu.in. We will present here and you can just start your explanation. Is this fine now?
sir, now okay.
Yeah, please share it to international conference at LFDC.edu.in.
Sir, give me a 5 minutes. I will present after 5 minutes before I am checking the screen share.
So you can just disable it, no problem. It will take 5 minutes. Yes. Now I invite Bharadwaj, Akshita. Akshita, final year students to present the paper.
Presentation. నాకు షేర్ చేయండి ఇంటర్నేషనల్ కాన్ఫరెన్స్ సార్ ఇంటర్నేషనల్
Good evening, everyone. My name is Pravanika, and on behalf of our team, me, Bharadwaj and Akshita, I would like to tell the topic that is supply chain instability. We are using this with delay differential equations. So today we'll be telling about the supply chain instability. That is, I will be discussing about the bullwhip effect, introduction to DDEs, and Bharadwaj will tell the mathematical modeling and half bifurcation. After which Akshita will be including real world insights into our presentation, and she'll be telling real world impact and key insights. So what this bullwhip effect is, small or minor fluctuations in retail demand can lead to amplified variability in the supply chain, which will be affecting wholesalers, distributors, and manufacturers. Next, there will be three primary reasons for delays in supply chains. That is, when we include outdated information, that is past information in the supply chain without amplifying only the present information. And the next one would be when we are doing mathematical models, we are not including past information when doing mathematical modeling. And the next one is we use DDEs where, like for example, if we if we place an order, then only the past information will not be included. Like only the current information will be included, which is a drawback for the supply chain. And then I hand it over to my teammate Bharadwaj.
Thank you, Veronica. And we are going to discuss about delay differential equations. The delay differential equations are type of differential equations which will be telling about the change in time, but taking account of the past time. Means normal ordinary differential equations means only we will tell the change in time with respect to the current time. But delay differential equations means we will be taking account of past time also. Here you can see that here you can see basic delay differential equation. Dx by dt equal to f of x of t comma x of t minus tau. So we will be in ordinary differential equations we will be using just f of x of t. But here in delay differential equation we are using x of t minus tau also to represent the delay in the or time or to represent the lag time or delay time. Next. And delay differential equations in this supply chain model gives us or explains how the amplification is increased or how the amplification is come and how we can predict that amplifications, and the key variables that we will be using to model this delay differential equation are I of t to represent inventory level and O of t for representing the order rate, and D of t for to tell the current demand, and tau as we know for time delay. And in this full delay differential equation, we are taking the or we are combining the both the equations like ordering policy and changing inventory level. So you can see the full delay differential equations O of t equal to alpha of s minus I of t minus tau plus df t minus tau minus dt. So O of t, as we discussed, it is a ordering rate, and alpha is a responsiveness factor, which means it adjusts its system stability according to the availability to fulfill the targeted stock. So the S represents target stock and the I represents inventory. I of t minus tau represents the stock at the inventory about the delay time ago. So, and the df of t minus tau represents forecasted demand with the same delay. So, d of forecasted demand forecasted demand means forecasted demand with delay means we are expecting how much demand we can expect from the past time ago, and we are not considering not only just this current time. We are taking account of the past time also, and you can see this all reconciled against a current demand which is leaving the warehouse right now. And to predict that oscillations or to predict that variability, we will be using a mathematical condition or mathematical state, which is known as half bifurcation. This generally means the system's equilibrium will lose at certain after a certain critical point, it loses its stability. As you can see here in the graph, on the left side, the graph line is the straight line, means it's a stable and manageable oscillations. We can it's a manageable oscillations, which will be we can manage if the order rate is if the order rate is more or if the order rate is less, up to that critical threshold we can manage. But once the after crossing the critical threshold, we cannot manage, and we can see that permanent and sustained oscillations, which results in forming of Goodwill effect. So, as Pravalika mentioned, Goodwill effect means the changing this at current time is related or dependent on the order rate we are giving at the past time. Means we will order any item based on the demand, which is 1 week ago or like 1 day ago. So sometimes we can get that correct only and we can manage, but sometimes we cannot manage that, and it leads to the stockouts and all. So using this half bifurcation, we are telling how after crossing certain time delay, the equations or the oscillations will be sustained and permanent. So which will be very cost effective. And the relevance to the Goodwill effect oscillations. So we are telling half bifurcation is useful for the Goodwill effect, but we have to say that solution, or we have to contribute to the solution. So we have to find a characteristic equation for the full delay differential equation we have discussed earlier. So for finding the roots of that characteristic equation, we can say up to what critical delay time we can manage the oscillations, and if the time delay crosses that critical threshold, the oscillations will not be manageable, and which will be sustained and permanent. And to walk you through the real life and tangible consequences of the Goodwill effect, my teammate Akshita will take up.
Thank you very much. As now we have seen the entire mathematical theory behind this process, I would like to talk about the practical implications. So let us see the slide. It says why mitigation matters. Now, before understanding the answer to this question, I would like to take you on about the consequences, where absence of mitigation and the consequences of it. So the absence of mitigation causes first consequences high operational costs, which means the entire stock out or sudden orders which lead to rush orders, panic orders lead to high operational costs. Maintenance of the orders at the factory lead to high operational costs. And the second is damage the customer trust. This happens because whenever there are stock outs, the customer visits the store in the hope of finding the product, but finds an empty rack and loses his trust with the factory or company. So here the damaged trust also is a big consequence. And thirdly, chaotic factory swings. So whenever there is build-up effect happening, the factory either produces in excessive or it stops production fully. So it is either with full supply or no supply at all. So the factory is always chaotic, and the chain that is in the supply, the distributors, the wholesalers, the retailers are all disturbed, and their relationship is not stable. And fourthly, inaccurate forecasting. This happens because the instability in the supply chain. Due to fast moving trends or fast moving in the market, there is no stability, and the market owners are unable to forecast based on the underlying data. So there is inaccurate forecasting. So these are the consequences. And now I think we can answer the question, Why mitigation matters? So let us answer the question why mitigation matters. So due to the bullwhip effect, there is amplified variability in the supply chain, which leads to stock outs or wasted inventory or even operational costs. So I would like to now take you all to a case study, real-time case study, which has experienced all these consequences because of the bullwhip effect. So the case study is named as the semiconductor crisis. So this case study began in the year 2020 when India hit pandemic. So firstly, the demand or the supply of the semiconductor chips were at normal or usual rate. But since the pandemic, people who were at home demanded for more electronic gadgets. There was demand of 3Cs, that is customer devices, communication devices and computers to stay engaged at home. So the market owners and the factory owners didn't anticipate this much demand and they were producing products at the usual rate. So they couldn't match to the demand and the supply. So here in this case, we can see the demand of the products was more and the supply was relatively very less. And the second thing that happened in this same case study was that the factories which anticipated the low demand knew that the prices of the semiconductor chips would rise and they started holding the chips. And then the pandemic already hit, but there was lockdown, which caused the restrictions on travel and shutdown of factories, which stopped the transfer of products. So there was ultimately low demand. So in this case, we can see the bullwhip effect happening, where in the first case we saw that there was high demand and low supply, and in the second case we saw that there was more supply and less demand. Here we can clearly see the bullwhip effect happening and its negative cascade of impacts. Now to overcome this, we have strategies. And coming to the strategies, we have practical mitigation strategies that has to be followed by the companies. So the first one with the drop picture says reduce lead times, which simply means that there should be less time gap between placing the order and receiving the order. So the less the time gap, the less there is the chance of instability of the supply chain. And secondly, we can see smooth ordering policies, SOP, which means that these policies should be made in such a way that they don't get disturbed or changed due to small noise of data. That means small change in demand doesn't affect the entire supply chain at once. So that is small spike in demand doesn't affect the entire supply chain. For example, smooth ordering policies like for a retailer who gets 100 units of products every week delivered, but on a single week he got an order of 125 units to deliver. So the normal traditional method would just do where a retailer would order 150 units, but with moving averages method, a retailer would order 106 units. And similarly, the third point, is improve information sharing, which means there should be visibility and transparency of the data right from the wholesalers to the consumers, so that there is no guesswork or there is no misinterpretation of the data, that the facts are revealed to the customers clearly. And fourthly, behavior training, which means the managers should be made capable of taking rational decisions during this demand and supply chain fluctuations. They should be made equipped enough to be able to handle these situations. So this DDE model serves us as a numerical stimulation or a test bed where we can test the products before, test the methodology before even releasing it into the market. So DDE helps with this process. Excuse me. So the key insights that I would like to draw from this entire project is that the first is we have identified that delay is the primary cause of the entire supply chain instability. So the delay differential equations help tackle that. And the second thing is we didn't just prove it by theory. We also used the real world events which confirmed or proved that the entire bullwhip process with the example of a semiconductor chip crisis. And the third is we gave effective solutions like reducing lead times and improving information sharing and improving smooth ordering policies and operational behavior of the managers, etc. Now I would like to pass on to Pravalika, who would like to take you all through the future directions and the closing thought.
So there is a lot of
scope for delay differential equations in supply chain instability. There are various fields like healthcare, management, etc., which uses delay differential equations. Also future directions include advanced behavioral modeling, data-driven parameterization, broader applications, policy and training programs. So I will hereby this work affirms that mathematical modeling of delays is central to understanding instability in model supply chains. By bridging delay differential equations and empirical observations of real-world disruptions, we underscore the value of rigorous quantitative analysis in guiding resilient and efficient supply chain management. So these are the references that we used in this. I would like to thank on behalf of our team for your time. Thank you.
Sir, any doubts?
Firstly, thanks to both of you. Why? Because you have come for today with nicely good presentations. I hope that one doubt. Delay time on specific delay time. If any specific time, delay time.
Yes, sir.
So that is any specific time or not?
Yes, the delay time is the time which is between the order is placed and when an order is received. So that time, the gap period or the time period which is between the receiving of order and placing of an order is known as that time delay. So based on if the time delay is very more, we can get this rubric effect will come into the action. Or if the time gap is very less, then we can manage the supply or we can manage the order.
Okay. So both this paper, what is your main contribution to give the society?
So just we want to tell one, we want to just contribute to that one solution that the delay differential equations can be used so that we can reduce this supply chain instability. And we have just only taken one node, that is supply chain node, that is only ordering rate. There will be many time delays which will be taking account for whole supply chain instability. So up to our knowledge, we have only taken one node of that supply chain, that is only inventory rate. But we have to see how the companies or how the factories will be maintaining the stock and all these things.
Okay, thank you. Good presentation. Any questions? Audience from audience? Thank you.
Thank you. Thank you so much.
Okay, thank you, my dear students, for giving a little bit different presentation, because usually mathematics represents only the theorems and the problems here. Yeah. But this was a little bit different, different concept.
Marita ma'am, can you hear me? Hello? Hello?
Yes, sir. Yes, sir.
Naveen sir. Hello?
Sir.
Yes, sir. I am hearing.
Hello?
Yes, sir. This is Harita.
Yeah. Ma'am, I'm asking. Naveen sir?
Sir.
Naveen sir, can you hear me?
Yes, I can hear you.
So one ma'am wants to present, Harita ma'am.
Okay.
So please give option to her to share her screen.
Okay. Ma'am, can you able to see the screen, ma'am? Harita ma'am.
Ma'am, you can proceed.
I am logging with the laptop, sir.
You proceed, ma'am. Yeah, it is coming, ma'am. It's showing. You can proceed, ma'am.
Thank you, sir. Yeah, good afternoon. Good evening, one and all. This is Harita. I am the scholar of Geetham University. Under the guidance of Dr. Ramakoteshwar sir, I am going to present a couple fixed point theorem for different metric spaces in 4 mapping. Now I am going to present next screen, sir. If you have to give me a sliding option, sir. Yeah, I'm going to present outline of my paper, that is abstract, introduction, main result, and some of the example. Now, these are the references are very useful for our paper. Now, coming to the abstract, in this paper we prove unique common coupled fixed point theorem for 4 mappings using this property, EA property, and a unique common coupled fixed point theorem for mapping satisfying W compatible property in multiplicative and non-multiplicative metric spaces. And also, some of the examples are generalizing some existing result in the current literature. Now, these are the keywords. Now, coming to introduction of this paper, earlierly, the authors are Bashirao et al. And introduced the multiplicative metric space in 2018. And also whose topological properties are also some proved some fixed point theorem. The couple fixed point is introduced by Bhaskar and Lakshmini Kantam. Later, some of the authors proved couple fixed and couple common fixed point theorems. The main aim of this paper is to prove a unique common couple fixed point theorem for 4 mapping using EA property. A unique common fixed point theorem for maps satisfying occasionally W compatible property in multiplicative in different metric spaces. This is the definition of paper. Now here X is a non-empty set in multiplicative metric spaces. Now these are the conditions. These are the conditions follows if it is a X is a multiplicative metric space. That is nothing but we have to take any 2 points whose distance is always greater than or equal to 1. Then XY belongs to X set. Here X is a non-set. Finally, here D1 is the distance of any 2 points is always greater than or equal to 1. Now second one is distance of xy equal to 1 if and only if x is equal to y. Now third one is this is the symmetrical property, and fourth one is triangular property. Now finally the pair of x comma d is a multiplicative metric space. Now these are the examples of multiplicative metric space. We are taking here example d of x comma y is equal to a to the power of modulus x minus y. Here a is always greater than 1. Here power is always positive. Now 1 to the power of 1 greater than any value we get more than 1. Now this example is satisfied multiplicative metric space. Now come to the second definition, that is nothing but multiplicative convergent to x in x if and only if distance from xn to x is always tends to 0. Here n tends to infinity. This sequence is converging to x in multiplicative metric space x comma d. Then limit n tends to infinity, distance from xn to y, which is equal to distance of x comma y for all y belongs to x. Now another definition, multiplicative Cauchy sequence. These all definitions are very, very useful to our paper. This third definition is a sequence xn is a multiplicative metric space. X comma t is said to be a multiplicative Cauchy sequence. Here epsilon is greater than 1. Now come to the fourth definition. The multiplicative metric space is complete if and only if here xn in x is a multiplicative convergent to in x. It definitely multiplicative Cauchy sequence.
Rita, go to your problem, main problem.
Our main problem is coming, sir, after slide. After definitions, main result is there. This is the another definition.
Skip the definitions.
Sorry, sir.
You skip the definitions.
Yeah. These all are definitions. After definition, main result is there, sir. This is another compatible, double compatible definition. This is the main result, sir. here we are taking 4 mapping, that is FG S sin T. In multiplicative metric space, we are taking 4 mapping. In 4 mapping are satisfied a unique common couple fixed point. That common couple fixed point unique number is 0, 0, sir. That point is satisfied this 4 mapping. Next slide. Yeah, this is the proof of that main result. We are taking all the definition concept in this result, in this proof. This is the example of 4 mapping. Now, these are all examples, only one solution, that is 0, 0 is the common solution, unique common solution of this 4 mapping. This is another theorem. We are taking 4 mapping again. This is the proof of second theorem. Yeah, actually my paper is a 4 mapping in metric spaces. In all cases, some of the conditions are satisfied. That is only finally we will get a unique common couple fixed point of 4 mappings here. Now by using present this paper, we referred, so these are the references to help our paper. Thank you, sir.
Narita,
Thank you, sir. Sir.
What is your main contribution of your paper?
Sir?
What is your main contribution of your work or paper?
Yeah, a unique common couple fixed point in metric space, sir. Previous author, sir, found out 3 mapping. Now I am proof by using 4 mapping, sir. That is a unique solution.
For unique solution.
Yes, sir.
Okay, audience, any questions from audience? No questions? Thank you, Harita.
Thank you, sir.
So any other participants who can present the paper?
Atmosphere is there, Sage Vijaya is there. Balayogi, Nadalakshmi.
Present, sir. Present, sir.
Okay, sir. Sir, Balayogi, will you be able to present the paper?
Yes, sir. Ready, sir. Present, sir. Ready.
Yeah, please, you can just start presenting the paper, sir.
I am sharing the screen, sir. Is it visible? The screen is visible, sir?
Okay. Okay, sir. Yes, sir, it is visible.
And is it okay, sir? Is it visible,
Yes,
the
sir.
screen?
Yes, sir. Yes, sir. You can start the presentation, sir.
Sir, the voice is clear. Can I start, sir?
Okay.
Yes. Yes, sir. Voice is clear, sir. You can
Very
start
good
the
evening
presentation.
to one and all respected chairperson of this international conference and all the higher authorities. This side, Dr. Balayogi from Unity College of Teacher Education, a teacher training college. I am the assistant professor. My topic today, methods and strategies for effective teaching of mathematics. There are different types will be there, different strategies, different techniques, different skills will be there while we are teaching mathematics, whether we are teaching primary school mathematics or middle level school mathematics, high school level or higher education at post-graduation and graduation level. So my topic mainly focus on what are the methods, what are the strategies can a teacher or a faculty or a teacher educator can use or can utilize in the teaching learning process inside and outside the classroom, so that the 21st century learner will be more participative, more active, more engaged inside the classroom along with the teacher. A small introduction you can see on the screen. A lot required from the mathematics teacher in terms of methods and strategies. As we are keep on saying that mathematics, sometimes students feel bored, sometimes students feel it will be very tough for them, even for the parents also. In this case, what is the methods we can utilize? What are the strategies or skills we can utilize so that the students can participate in a good way, or happy learning will be done inside the classroom for the teachers and students. These are the objectives. You can see, know about mathematics, its importance, and some important faults that the teaching of mathematics, and we can learn various methods of teaching in mathematics. The methodology is mainly focused on the secondary data taken from the renowned research articles and position papers and so on. As you can see on the screen, 1,000 teachers, 1,000 methods. Every teacher will use different methods, different techniques or strategies in a classrooms. Every teacher is different, but ultimately we have to give the best solution or best problem solving techniques or the best definitions to the students so that they can understand in an easy way, in a better way. Next, what is the teaching? A small teaching, as we know that it is a process of interaction and giving the knowledge and understanding to the students. And teaching method, it is a systematic plan followed in presenting material for towards the instruction. Next, teaching, what is the why your teaching methods are important or strategies are important? What its main objective means to provide guidance for the teaching process, to present the alignment of what the teacher decides. You want to present a topic, you want to present a problem solving, a theorem, a proof, a lemma, so on and so on. But how they are presenting, that is important. And its importance is to assist the students in mastering the course content, to make the teacher in determining what best approach to use in the process. Lot of literature review, previous studies also happened in the topic is different methods of teaching. And the teaching methods, different types will be there, learners and method. So I want to teach towards the student, what the students required, what the student is want, that is learner center method. And teacher center method is also there. One side only the teacher will focus, but mainly mixed method, learner center and teacher method is very important, and content center method is also very important. So in the screen, different theories will be there. Approach means what to teach, method means how to teach, and finally technique means teaching technology or a skill. So various methods will keep on going. First method is lecture method. As we know that lecture method, one side method, teacher will give the instructions, teacher is active and student is passive. That is the lecture method. And discussion method, classroom discussion method will be there. Next, group discussion will be there. And in the form discussion, in the form of symposium also will be there. Seminars, conferences also will be there. So these are another method. Next method is a demonstration method. Teacher demonstrating, showing some, telling the students the point of emphasis. The demonstration is useful mostly in importing psychomotor skills and lessons that require practical knowledge. Next, I have lecture come demonstration. I will give the lecture, I will give the talking, and I will demonstration also together. Next, my method is inductive and deductive reasoning. Usually, when we're solving the problem, it is a process of, I will give some examples and observation to reach the conclusion. So I will talk about number system or statistics or set theory, whatever it may be. And a deductive reason, when you move from a general conclusion to a specific one, that is called deductive. Next, I'll move on to the analytic and synthetic method. It is derived from the analysis. It means breaking up the parts. So step 1, step 2, step 3, step 4, I am breaking up. And synthetic, all the parts will be clubbed together. Next, I'll move on to another important method, that is heuristic method. In the heuristic method is to discovery. It's of teaching of a method which involve of placing students as far as possible in the attitude of the discovery method. We have to give one problem solving, let them do, let them solve, let them do by themselves, so that we'll give the freedom of learning. It's a pure discovery method of learning. But here, role of the teacher is, teacher should be a guide, a mentor, so that students can do their things in a systematic way. And problem solving method is also one of the important methods, so that students can understand in a easy way. And it's like a scientific method. It will develop critical thinking, decision making, and examining and reflective thinking also will be there. Next, project method. So I will give one project to the students. This method is based on learning by doing. Pupil perform constructivist activities in natural conditions. You can give any method like gardening method, or we can give grocery, or they can go for the shopping. So they will do the project and they will submit the result in front of their students and teacher also. It engages the students with hands-on learning and empower the students to take ownership of their own education. Next, a lot of merits will be there and demerits. Sometimes it is time consuming, a lot of resources are required. And the questioning method also, sometimes we have to give students to arouse interest and curiosity, to stimulate the discussion. The questioning method is also very, buzz groups is also another method, so that the room filled with noise, each group you have to divide into the groups, and they have to pair and they have to talk together and they will present their discussions. Role playing also very important, so that students can attach with their real life situation problems. And inquiry and discovery method. Some of the strategies also, if you see some of the strategies of teaching mathematics, explicit instruction, hands-on learning, visual strategies, scaffolding, differentiated instruction, and connecting to real world. Next, conclusion, mathematics teachers are to be encouraged to have very good graphs of all the methods and strategies. Teachers should endeavor to continue different methods when teaching mathematics. One of the qualities for successful teaching as a good methodology, and the teacher must know the best techniques, methods, strategies, presenting his or ideas to the students, putting into consideration. Effective teaching method or strategies involves all activities which would help inspire the students to learn and create ideas, and success of teaching depends on the method and strategies apported by the teacher inside the class, outside the classroom. So some of the references you can see on the screen, but finally, if I cannot learn the way you teach, but will you teach me way I can learn? That is what the students of this 21st century are taking care. So we need to go according to the learner-centered, student-centered. So thank you very much, the authorities, for giving an opportunity. Thank you.
Good presentation, Balan Garu. I ask you 3 questions.
Yes, sir.
Which method better to teach nowadays, as per your suggestion?
Sorry, sir. What, sir?
Which method better to teach?
Sir, the method, yes, sir. The best method is learner-centered. So we have to teach according to the students' requirements, according to the students' needs and their understanding. If you are going one way, if you are going as you like, as you prepared, sometimes it is very difficulty in the classroom, sir. So I hope learner-centered in this 21st century is the best method.
Your side. Now, what is your due to society from your topic?
Yes, sir. Yes, sir. So, as we know that now in this globalization, in this information technology world, lot of changes are happening, especially inside and outside the classroom, and teaching is very tough. So society demands, society community requirements, and parents, stakeholders, their requirements are very high. So every day, according to the changes in the society, you have to change your teaching methods, teaching strategies, your lesson planning, your examples, your problem solving strategies should be done so that we can uplift the teaching in the 21st century.
Okay. Any questions from audience? Okay, thank you, Balindu.
Thank you very much, sir. Thanks.
Thank you, sir. Harita ma'am, are you there in the online, ma'am? Harita ma'am, can you able to hear my voice, ma'am? Anyone like to present the paper? Anyone would like to present the paper? Please, you can raise your
Yes,
hand.
sir. Yes, sir. I am available. Ramya Narayanan.
Okay, ma'am. Please, if you can share your PPT, you can just start your presentation. Ma'am.
Okay, sir. Okay, sir. Thank you, sir. So my screen is visible, sir.
Yeah, it's visible, but
Should I start?
no, it's partially. Yeah, check it once, ma'am.
Excuse me, sir.
You
The
just
voice
share,
is not.
no, you just share the full PPT, full screen. Full screen, you put the option.
So voice is not audible. My screen is visible.
It's not visible, but it's saying you are presenting it. But you have not selected the window.
Okay.
Please select the whole window.
It's.
Ma'am, if it is difficult to present that, if you can't share that one, you just send it to international mail ID, we will just open it. Yeah, already we got
Sir, is
your.
this okay? Is my screen visible?
Yes, yes, ma'am. Put it in the presentation mode. Ma'am. Presentation mode. And from the beginning, you have an option top. You can see that one.
Down there is a presentation.
Yeah, down also you can go, and the top also we have from the beginning. An option you have on the top. You can just click on that one from the beginning. From the yes, on the top one. Left side you have an option and file. Below that file name you have from the beginning. Then extreme top left corner. Otherwise, we'll share the PPT, ma'am. You can start your explanation, ma'am.
Okay, sir.
Ma'am, put it in the full screen, ma'am. Full screen mode option. Right side in the down, you have here the volume adjustment, ma'am. Right side. Yes, ma'am. Yes, ma'am. Yes.
It's okay, I'll display it.
Ma'am, there is a. We are displaying, ma'am. You can start your explanation, ma'am.
Sir, is this okay?
It's okay. Yeah, it's okay, ma'am. Okay.
I'm good evening to everyone. I'm Ramya, research scholar from SCSPME University, Tamil Nadu. I'm going to present behavior portfolio optimization using fuzzy linear programming problem. It won't move to next page soon. The abstract of my paper is, sir, am I audible?
Yes, ma'am, you are audible.
My screen is open, visible, sir?
Ma'am, 1 minute, ma'am. You are on the line.
Abstract portion.
Yes, ma'am. Just put it in the full screen
Yes.
option, ma'am.
Yes, ma'am. Yes, sir.
Can you just put it
My,
yeah, ma'am. Full screen
yes, sir.
option. Right below that you have like near the volume you have a small option, ma'am, a small icon. Just click on that icon. Yes, ma'am, you can start presentation.
The study introduces a behavioral fuzzy linear programming model for retail portfolio optimization that integrates cognitive biases into fuzzy decision-making framework. While fuzzy linear programming addresses uncertainty in real expectations and risks, and behavioral finance accounts for investors' rationalities like anchoring, herding, and overconfidence, the combined application remains underexplored. This model uses triangular fuzzy numbers to represent behavioral distortions in return, risk, and allocation preferences, offering a more realistic formulation of investor decision making. A case-based numerical example demonstrates the model's applicability using Excel solver. Results show that incorporating behavioral biases leads to notably different asset allocations compared to a conventional bias-neutral FLP model. The study highlights the potential of BFLP to bridge mathematical optimization and psychological realism in small-scale investment strategy. In the next slide, I have I can go to other slides, sir. Madam, I can move to other slides, ma'am.
Just scroll the slide, ma'am. Ma'am, we can do one thing. Now we'll present the slides PPT. You just say like start your explanation, ma'am.
Okay, sir.
Is that okay for you, ma'am? If you want to just go for the next slide, you say next, ma'am.
So I just once I refresh and I get back to you, sir.
No, just you to stop share screen. We will share the screen. You just explain that one, ma'am.
Okay, sir. So my idea of presentation is while choosing start selection, rational thinkers only not take participate. When human involved, their psychological biases also take part. Sir.
Sure,
So how to separately they are doing for rational thinkers how to decide optimal portfolio. In the behavioral finance, they are doing how behavioral biases such as anchoring, overconfidence, like that, how influence in deciding optimal portfolios. In my presentation, why don't we fuse together and even after the behavioral biases take part in taking decision making in optimal portfolio selection, how one can reach their optimality, how one can improve their my expected return and minimize their expected loss. This is the main idea.
Ma'am, we are sharing the PPT, ma'am.
Sir?
We are sharing the PPT. Just look at the first slide, ma'am. This is your starting PPT.
Sir. This is one. This one, sir.
Will you want to continue from here or you want to go for the second slide? How you continue?
Sir, I can't hear your voice, sir.
Yes, ma'am. We can continue, ma'am, from the second slide.
This is the main idea of my presentation, sir.
Yes, ma'am.
I'm just presenting a model or one practical model to this and show how to work out the concept. So,
Okay.
am I audible?
Yes. We can able to see your presentation there.
Sir?
Ma'am, we can see your presentation. You can just continue, ma'am.
Okay.
Carry on.
So here I am showing some of my research, literature review, the work already done. Here is my situation. I fit into my situation to retail investor perspective. Sir, am I audible? My screen is present. Okay, sir. This is my case. Retail investors with moderate income levels often invest a limited portion, typically 20 to 30% of their earnings in financial markets. Despite the modest investment, their decisions are strongly influenced by behavioral biases such as overconfidence, anchoring, and herding. Due to uncertain returns and personal preferences, fuzzy logic offers a suitable framework to model this complexity. The objective of my problem is to construct and solve a fuzzy linear programming problem using triangular fuzzy numbers that accounts for behavioral biases. For an individual investing 25% of their monthly income, say rupees 20,000 to 80,000 of their salary, the fuzzy parameters are characterized as three categories. One is pessimistic estimate, most likely estimate, and optimistic estimate. The investment, if we consider the investment budget, will be ranges from 18,000 to 20,000 rupees. I have constructed my constraints as fuzzy expected returns for three decision variables to 6, 7 to 9%, and for XB 5 to 8%. For C, for start C, the expected returns percentage will vary from 4 to 7. The same for risk estimates for stock A for 4 to 6%, for B 2 to 4%, and for C, if we choose C, 1 to 3%, and the risk tolerance varies from 3.5 to 4.5. Next, XA, the constraints I have fixed for XA for deciding the stock A will be 9,000 to 11,000 and 10,000 to 12,000, and for XA, 12,000 to 14,000. Next, I have constructed my programming problem like this. Next, I have converted my fuzzy number to crisp number by using the formula center of gravity, which will be A plus M plus B by 3. Then after converting all this, my model will appear like this, final crisp LPP like this. Then using fuzzy solver, I have found rupees 10,000 investing in the stock A will be optimal decision, and for B and C we can invest for rupees 5,000 for each. Then the maximum return will appear 1,316, and the risk constraint will be in 800. My conclusion will be the study demonstrates that integrating fuzzy linear programming with behavioral finance can effectively support small-scale retail investment decisions by using triangular fuzzy numbers to represent expected returns, risk, and behavioral biases such as anchoring, herding, and overconfidence. The model accounts for uncertainty and investor subjectivity. It offers a flexible, psychological aligned framework for portfolio optimization. However, limitations include static behavioral assumptions, subjectively defined fuzzy parameters, and use of crisp approximation in Excel solver. Real-time market factors like transaction costs are also excluded. Future improvements may involve dynamic behavioral modeling, broader asset inclusion, integrating with machine learning forecasters, and use of empirical investor data. This development can enhance the realism and adaptability of the model, making behavioral portfolio optimization more practical and accessible. Here I have mentioned some of the references I have made. Thank you, sir. Thank you, sir. Sir, I am.
Hello. Hello, madam.
Yes, sir.
Madam, how best you can say that the today's market fluctuations with this fuzzy model?
Sorry, sir, I can't hear your voice clearly, sir.
Yeah, you said fuzzy model is best with regard to LPB models.
So sorry.
Is it audible or not?
Your voice is not so clear, sir.
Hello? Hello? Hello?
Hello, sir.
Madam, is it okay? Is it audible?
Now it's okay, sir.
You are saying that fuzzy models are more useful rather than the LPB models.
Hi, sir.
Can you find the fluctuations in the market, madam? Today, the markets are very fluctuating.
Yes,
And
sir.
can you find the fluctuations with this by using the fuzzy models, madam?
Yes, sir. Surely, sir. Because fuzzy models basically handle the uncertainty, sir. So fuzzy models are, from my point of view, it's useful tools.
We are using fuzzy model, but references are not indicated the main difference of the fuzzy, madam. LZS reference. Madam, you include reference of LZA 1965 is the base for the fuzzy things. The author, main author for the is fuzzy models.
Nice, sir.
Yes. Well, thank you.
Thank you very much, ma'am. Still any participants to present the paper? Harita, ma'am? Ma'am, are you there? Harita, ma'am. Anyone who is going to present the paper? Okay, dear participants, if there are no paper presentations, we would like to just close this session for today. And again, tomorrow we will be back at 9 o'clock in the International Conference of Emerging Trends in Science and Technology. And tomorrow we have speakers from the various universities. They are going to give the sections and followed by the paper presentations. And if you want to just give the paper presentation, please join in the morning section. We will just put a link in the WhatsApp group. So please join the WhatsApp group and you can present your papers. Thank you. Thank you, everyone.
Thank you for Degree College. Always contribute to this opportunity. Thank you.
Thank you, sir. Thank you very much. You have accepted our invitation and you have took a very valuable and precious time to come here. And very patiently, you have just sorted out all the participants. And thank you for accepting our invitation and sparing time for our international conference. Thank you very much, sir. Thank you, sir.